All right, so last one here, and their explanation is sufficient. I just wanted to kind of make sure that what we had was just plenty of examples, making sure we understand the process. The process is exactly the same with this problem. So let me get my tools up and ready, and ready to roll here. All right, so here we go. We start this thing off exactly the same way. We need to find our z-score. And so it's really the interpretation. It's like, what does this mean? So we start off and we know, as always, we identify our mean. And so our mean is 20. Our standard deviation is 1.2. Our first step is to find our z-score given what we know. Well, in this particular problem, we know that the minimum length that a baby could be and still have a length amongst the top 25%. So we know that this is our 25% up here. And what we're looking for is that cutoff. Like, what does the length of that baby need to be to put them in this category? That's the hardest part of this problem. Like, so if you're in the top 25th percentile, then what is that cutoff height or length that you need to be in that percentile? So this is a very applicable situation. I mean, we read this data every day. When you have a kid, or if you work as a nurse with babies, I'm sure you're going to have to really have an application of this. So same process. I mean, this is exactly the same. It's just an application of what we've done earlier. So we know 25% is up here. We want to find that x value that separates that 25% from the lowest part. To find that lower part, we take the 1 minus the 25, and we find out that we have 0.75 or 75%. With that, we take that and we have to go to our table. They've been using their calculator, but we're going to go to our table, and from our table we're looking for 0.75. So we come inside, we've got 0.74857 and 0.75157. So remember, our number in the middle is 0.75. We need to determine which one has a smaller difference, which one's closer. So 0.75 minus 0.74857, and we find out that difference for the first one is 0.0143, and then 0.75157 minus 0.75, and we find out that guy is 0.00157. So this guy's our winner. Let's put our calculator away. So now we take that, we calculate our z-score from him, so we cruise across. So we got 0.6, we cruise up 7, so our z-score is going to be 0.67. We bring that back with us to our previous slide. So our z-score is equal to 0.67, and so we're going to use that z-score to find that x value. So now we're going to find our x value. We use our formula derived from our z-score, which is x equals z times the standard deviation plus the mean. We plug our numbers in, and so we have x is equal to a z-score of 0.67 times our standard deviation of 1.2 plus our mean of 20. Pull out our calculator and clear that. So we got 0.67, open parentheses, 1.2 plus 20, and we find out that that length would be x is equal to 20.804. Remember, we started off and our original question had a mean of 20.0. We can't forget that had a decimal place on it, so 20.0. So we'll round this to 2 decimal places, so that means that would be x is equal to 20.80, and then obviously that 0 could drop if you wanted to. Alright, so that kind of hits all of your different problems you're going to come across in the homework. There is the wording of one of the problems is a little more confusing than that, but remember, you're using these application videos here to work through those. Alright, good luck.